Hello everyone and welcome to the Decarbonisation of Heat session at ENIC 2020. I'm Paul Clark, I'm Vice President of Policy and Marketing at Passive Systems. In the session before this, we heard about what the gas networks are doing to enable the transition to hydrogen-based heat across Britain. We will now hear from the electricity networks on what they are doing to decarbonise Britain's heating. Specifically, there will be a presentation from UK Power Networks on their heat electrification projects, followed by Delta EE discussing their project for National Grid ESO 4D heat. We will then move into our panel on cross-vector solutions for the decarbonisation of heat. As always, if you have any questions, please ask them in the chat panel to the right of your screen. And now I'll hand over to the electricity networks.
Hi everyone, my name is Ashita Anand and I'm an Innovation Project Lead at the UK Power Networks. I'm an electrical engineer and I have international experience with detailed power systems engineering and energy utilities regulation. At the UK Power Networks, I'm working alongside some very bright minds to advance our strategy to decarbonize the heating sector, which is the single biggest source of greenhouse gas emissions in the UK. The government's ambitious net zero by 2050 target is a strong driver to improve the environment, which is something that's very important to me and we know is the highest priority for our stakeholders. Heat decarbonization is at an early stage as well, with a lot of questions yet to be answered. We have a real opportunity here to make a big difference in a lot of lives as we pursue a cleaner future for heat. I'm excited to be at the UK Power Networks, where we are at the forefront of understanding heat decarbonization and taking concrete actions now to not only enable but to accelerate the net zero target. At UK Power Networks, we take great pride in connecting with and hearing from our stakeholders to drive our actions. We believe this is essential in order to deliver on our vision of being a respected corporate citizen and sustainably cost efficient. Tackling the challenges of decarbonizing heat will require a high rigor of engagement and collaboration, which is something UK Power Networks is well equipped to do, and we are doing in this area. Stakeholders have told us that factors such as lack of policy and lack of awareness are some of the key barriers to the uptake of low carbon technologies. Collaboration is paramount to navigating those challenges. It will enable us to address concerns such as low visibility of LCT uptake, higher network reinforcement and service alteration costs, unclear path to the future of heat, customers who are unaware of the need to decarbonize, and even leaving behind disadvantaged or fuel-poor customers. No one party has all the answers, so we must work together with communities, local authorities, and installers, for example, to enable us to jointly unlock economic, environmental, as well as social benefits. Through Community Heat, the people of Barkham are helping UK Power Networks create a model community roadmap for reaching a zero-carbon heating future for off-gas grid areas. These communities rely on very carbon-intensive options, such as oil, coal, or wood chips to heat their homes and to cook. UK Power Networks will work with community energy groups and local partners to research, gather data, and compare approaches for reducing the village's carbon emissions from household heating. We're conducting deep engagements with over 600 residents through our project partner Avesco, and building network and techno-economic models through our other project partner Bureau Happold to explore the different decarbonization options available. One of the ways we're actually going to do this is by installing meters to help us understand the residents' winter energy usage this year. The data we collect and the simulations we run will investigate the costs, efficiency, and electricity network impact of multiple different approaches, including shared district heating, medium-sized heat pumps serving a few properties, or even the personal electrical heat pump installed at each property. We'll also be looking at potential community finance models and analyze how other smart technologies, such as electric vehicles and solar power, could play a role. With a clear plan in place, residents will understand what a low-carbon future could look like. The research and trial design study will be replicable across the UK to the 4 million properties like those in Barkham. The net zero targets are quite ambitious and will require everybody to do their part. With such a large-scale change expected in such a short period of time, communities need to be at the heart of the solution. There is a lot of untapped opportunity to reduce emissions within communities. Through the Community Heat project, for example, we're exploring the benefits of a coordinated approach to heat decarbonization versus the uncoordinated approach where each customer decides on their own solution. We believe it would be beneficial for consumers as well as the network to pursue a coordinated approach. By working directly with the community, we empower them to work together and achieve net zero and give them the tools needed to have a new type of energy system.
Hi, thanks for joining us today. My name is Rona Mitchell and I'm an Innovation Project Lead at UK Power Networks. And today I'm going to be talking to you about heat decarbonisation and the various different projects and schemes we have going on at UK Power Networks. Last year, the UK signed into law a net zero target by 2050, and that's really important to the electricity networks for a number of reasons. Over the last 10 years or so, we've seen huge strides forward with renewable energy connecting to the distribution network. And in the last number of years, we've also seen a huge increase in the prevalence of electric vehicles on the network. One of the next major sources of carbon dioxide in the UK, which must be reduced as we proceed towards net zero, is heating. As electricity networks prepare to facilitate the net zero transition, we are continuing to receive feedback from customers and stakeholders that it really is an area we should continue to focus more on. Customers quite rightly expect that the electricity networks that supply them are going to be innovating to ensure that we can progress to the net zero transition at best value for everyone. Another really important area of the net zero transition is making sure that we are looking after those in need, people who may be experiencing fuel poverty or living in other vulnerable circumstances. And we need to make sure that we innovate to ensure that we facilitate a just transition for all and not leave anyone behind. I think we have a good understanding in industry why the decarbonisation of heat is so important to the work that we're doing now and looking forward into the future. The Heat Street project is a research project that we recently started to really start to understand more about heat decarbonisation and what it might mean for electricity networks going forward. As we know, as heat decarbonisation progresses, we're likely to see an increasing number in heat pumps that are electrically powered throughout our network. To date, we've had about 20,000 domestic heat pumps installed, and by the end of 2028, we expect this to increase by a factor of 10. So we'll have about 200,000 heat pumps on the network. That's going to mean quite a lot of changes for us, particularly at the low voltage levels. So we're doing all that we can to improve our forecasts and models to understand what are the likely impacts and what we need to do to better react to this. One of the really important things that will impact how the electricity network perceives heat decarbonisation is energy efficiency measures that are used in homes. A lot of heat now that goes into homes is lost through thermally inefficient windows, doors, floors, and roofs. So we've been doing some work in the Heat Street project to better understand how those energy efficiency measures, which a lot of which will be going in through the Green Homes Grant, hopefully in the next 6 months, and what that will mean to the overall electric load that is required to heat a home if they choose to install a heat pump. So throughout the Heat Street project, as well as doing desk-based research, we held a number of customer and stakeholder workshops to understand what the different drivers and barriers are across energy efficiency and low-carbon heating take-up. We've also looked closely at where it might be possible and when hydrogen may reach certain households across our patch. We've worked with industry bodies and local councils to better shape our forecasts to understand if we've missed anything or just to check that our views are broadly in line with what our customers and stakeholders are experiencing. We've worked really closely with the Association for Decentralized Energy throughout this last year as we've produced our heat strategy. They do a lot of active work in the policy space and recently put out their zoning paper, which puts out their view for how zoning can be used to decarbonize areas at best value. This plays hand in hand with local area energy plans. And the idea of zoning is that specific areas could be zoned for specific things. So you might have a hydrogen zone, you might have a heat pump zone, you might have a heat network zone where the legislation changes to say, actually, if you're building new properties in this area and there's an existing heat network, you are obligated to connect to them. And the idea is that this will provide a framework that can be used to support councils to make decisions that will ensure a green future. At the end of the Heat Street project, we're going to be publishing results in a similar way to our DFES project. That means that low carbon heating and energy efficiency uptake scenarios will be visible in Excel spreadsheet format, and that will be for all across the UK Power Networks areas. We are definitely on a journey with heat decarbonisation, and we are continually looking for opportunities to engage with other stakeholders and customers, as well as pursuing new projects. So if you have an idea in this space, please don't hesitate to get in touch.
Energy efficiency and heat decarbonisation complement each other well, and will continue to go hand in hand as we move towards a net zero carbon future. Improving the energy efficiency of a building means that any new low carbon technology, like a heat pump for example, that is installed or retrofitted into a home will be able to run much more efficiently. This is because a lot less electricity is required to heat a home, which retains its heat through energy efficiency measures such as double glazed windows or loft insulation. It's actually a win-win because it will also help save consumers money on their bills, given that their overall energy use for heating will be less. On the network side, a combination of energy efficiency measures and low energy consumption can reduce the potential peak load on our network. That means there's more capacity left to connect other technology like renewable energy, which can help us further facilitate net zero and avoid costly network infrastructure upgrades. What we've seen through our Low Carbon London project and other studies is that the load curve for heat pumps connected to our network has a peak in the morning and in the evening. This makes sense. As people get up in the morning and get ready for their day, they'll increase their energy use, say by turning on their lights, adjusting their heat, and making their breakfast. In the evening, we can see a similar peak as the household load increases at dinner time after people return from work. That represents a typical load curve, but it may be changing with COVID-19 and people working from home. Energy efficiency also means that people could participate in flexibility services. They could flex their demand, meaning the electricity is on earlier in the day or a little later at night, without compromising on a warm home because of the improved energy efficiency. Through Firefly, we also looked at the potential for energy efficiency to help defer network reinforcement. As part of this project, we analyzed the EPC ratings at households around a selection of some of our substations. We found that there was good potential for energy efficiency upgrades to get higher ratings. This is great for consumers because it means there is a potential to reduce energy bills while helping networks reduce the overall load on the network. The findings from the project have fed into Rona's Heat Street project, which she talked about earlier. Heat Street is building on the concept, but going further to specifically forecast and identify which measures would be most useful in specific areas. As Rona said, in some areas, certain energy efficiency measures may make sense, but in others, different measures might be more effective. Another pathway we're currently exploring to deliver a great service experience to our customers is by exploring the hybrid pathway. Hybrids mean a combination of electric heating with green gas, or in the future even hydrogen, that could be used to heat homes around the UK. We've partnered with the gas network, Wales and West Utilities, and a technology partner, Passive Systems, to break new ground on the High Compact project. This project will run from winter this year until April next year. In the project, we're installing new hybrid systems in energy consumers' homes alongside smart control software. We're installing 6 of the new devices at homes in UK Power Networks and Wales and West Utilities areas. The aim of the project is to explore the customer journey, understand how the devices are used and what energy efficiency savings they can make, and explore the potential for flexibility offered through the new equipment. The unit we're installing is a single unit hybrid heating system. Most other units have a separate electrical heat pump and a boiler, which means they can be larger and not as easy to install or run for consumers. A single unit hybrid system, therefore, can make it as easy as possible for consumers to make the switch to low carbon heating. The systems will be fitted directly into the customers' homes and hung on the wall in the place of their conventional gas boilers. With the smart control software, the equipment can flexibly switch between electricity, gas, or occasionally use even both at the same time. The device decides, based on cost, the amount of carbon being used, or whether there's a peak in demand on the network. High Compact will enable us to understand the role that hybridization might play in helping us facilitate a net zero, low carbon heating future for our customers. This will unlock benefits for all and make sure everyone can access those benefits. Thanks so much for watching our presentation today. We really appreciate it. Again, you can get in touch with me at ashita.anand@ukpowernetworks.co.uk or Rona on rona.mitchell@ukpowernetworks.co.uk. We would be delighted to hear from you and work together in the future to help facilitate the net zero heating revolution.
Good afternoon, everyone. I'm Matt Myers, and today I'm delighted to give you an overview of the 4D Heat project. 4D Heat was a joint NIA project between National Grid ESO and SSEN. The project was delivered by Delta EE, Everose, and Passive Systems. 4D Heat seeks to answer what is the maximum volume of wind energy that the ESO could avoid having to curtail by incentivizing residential heating turn-up at times of constraint. These constraint issues arise predominantly due to an abundance of onshore wind power up in Scotland and limited transmission network capacity to transmit this power down south at certain times to England and Wales. The idea behind 4D Heat is that hopefully we can deliver savings to the end consumer, protect the distribution network, and help the ESO save on constraint costs, all by turning up off-gas grid electric heating in Scotland. Also, by avoiding curtailment of wind, there are added carbon benefits as well as societal benefits. In terms of the key outputs, we wanted to identify the difference we can make with a domestic turn-up service to overall wind curtailment, look at the cost benefit of doing this, and lastly, examine the route to market to make this all happen. The modeling that we did for the project was based on scenarios that isolated the differing effects of installing smart controls, offering homes a financial incentive to increase the demand at times of curtailment, and adopting time of use tariffs, which reflects the wholesale electricity price plus variable distribution use of system charges, such as like the Octopus Agile tariff structure. We also looked at two different modeling years, 2020 and 2030. And in our 2020 modeling, we took account of the legacy environment of RTS homes, which are homes that have a type of electricity meter with an inbuilt remote control mechanism that uses BBC long wave radio to allow for scheduling of storage, heater, and hot water demand to avoid distribution network constraints. There are a significant number of homes with these RTS meters, with over 1.6 million RTS meters currently in operation across GB. So the 2020 cases represented a business as usual type case, and we looked at the additional effects of installing smart controls as well as explicit wind incentivization. And we also looked separately at addressing the RTS homes versus leaving the RTS homes as is. In our 2030 scenarios, we assumed all the RTS homes were converted and there were no more RTS meters. And we looked there at the full effects of smart controls, the explicit wind incentivization, as well as the dynamic time of use tariffs. A lot of the modeling we did for the project centered around the home space heating and hot water demand profiles. In order to formulate these profiles, we used base existing hot water and heating demand profiles. And in order to derive the different scenario home space heating and hot water profiles, we also needed the curtailed in wind energy predictions for Scotland So in our cases where we were looking at consuming curtailed wind, we could follow those profiles, as well as the electricity tariff profiles, especially for the cases where we were drawing on the dynamic time of use tariffs to try and see what the demand profiles would look in a case where those were being followed. The modeling also drew into the kind of central modeling that we did, the overall housing stock. We also looked at the low voltage feeder headrooms available to ensure we didn't exceed the network capacity of the low voltage network. And lastly, we also needed the information on the curtailed wind use tariff discount. So essentially the potential value or the incentive that the ESO could provide for homes to turn up their heating at times of constraint. And what the model did then was select on a day-by-day basis the most cost-effective demand profile for each home, whether that be reacting to a normal tariff profile or following the wind curtailment profile. So essentially at all times we were acting in the home's best interest, minimizing their costs, subject to not breaking the low voltage distribution network. We also from this calculated for each home the normal tariffed energy used, as well as the otherwise curtailed wind energy used. And from that, we could then gather the total amount or calculate the total amount of curtailed wind energy absorbed, and then this was scaled up to all of Off Gas Grid Scotland. Separately, we could calculate the system costs in each case for each home in each scenario, and we use this as an input to our CBA. Taking a look at the main findings for the 2020 scenarios, first looking at excluding the RTS homes, we saw that you can get a total reduction of 54 gigawatt hours of otherwise curtailed wind. This amounts to about 4% of the total wind curtailment forecast for 2020. And we see a lot of this is actually made up by the indirect effects of adding smart controls. And then further, this is boosted by explicitly incentivizing homes to consume wind at times of curtailment. If we include the homes with RTS meters, we can significantly increase the otherwise curtailed wind consumed. And here we have a total of 222 gigawatt hours, and this amounts to 17% of the total wind curtailment forecast for 2020. Once again, with a large portion of this just being made up through the indirect effects of fitting smart controls. Taking a look at our 2030 scenarios, we see a much higher total of otherwise curtailed wind energy consumed at 450 gigawatt hours, and this amounts to about 9% of the total wind curtailment forecast for 2030. Looking at how this is made up, you can see once again there's a significant portion that comes from adding smart controls, what just smart controls themselves do. Looking at the next batch of results along, we see that dynamic time of use tariffs also allow a further significant proportion of otherwise curtailed wind to be consumed. And this, on the surface of it, actually can be seen to be fairly obvious in the sense that you would expect that the dynamic time of use tariff profile would reflect low costs at times where there's a lot of wind on the system and potentially being curtailed. And lastly, we see that additional benefits, roughly say a third of the additional final benefit, comes from having an explicit incentive to consume wind at times of curtailment. So essentially we can get quite a way of the way there just by relying on, for example, smart controls and dynamic time of use tariffs. This chart also shows that even though we have many more heat pumps in our 2030 scenarios, a lot of the kind of heavy lifting is being done by the storage heaters. And this is just because they consume a lot more power than the heat pumps, which are operating with a much higher coefficient of performance. Taking a look at the main findings of the cost-benefit analysis, first up, I want to be clear that the 4D heat concept delivers significant system-wide benefits that range from £11 million in the worst case scenario that we looked at to £304 million of benefits in the best case scenario that we looked at. And this is all on a 10-year net present value basis. Looking at where these benefits arise from, the majority of these benefits in most cases arise just from the direct benefits of fitting smart controls and optimizing home heating, whether this be just generally or in accordance with time of use tariffs. There's also significant benefit from the avoided wind constraint payments, and further additional benefits come from the environmental and societal benefits that are largely comprised of avoided CO2 emissions. I've put on the slide here the per year savings for the ultimate case we looked at, where we had the smart controls implemented plus the dynamic time of use tariffs, as well as an explicit incentive to consume curtailed wind. In terms of what this all translates into payback-wise, looking at the system-wide payback, in our 2020 scenarios, this ranged from about 4.5 to 6.5 years across the different scenarios. And in 2030, the paybacks range from as little as 1 year to about 7 years. The headline conclusion is that flexing Scottish off-gas grid domestic electric heating can result in reducing the amount of wind generation needing to be curtailed. This can also provide substantial costs and CO2 savings. Such an arrangement could result in avoiding up to 17% of curtailed wind in 2020 and up to 9% of forecast curtailed wind in 2030. And this could save in the region of £24 million per year in avoided constraint payment costs alone. There are, however, some fundamental limits to the use of electric heating for managing curtailments, and I thought I'd just draw this out by highlighting that the fact that by 2030, the magnitude of curtailed wind will be more than 3 times greater than the total annual space heating and hot water demands of all of electrically heated homes in off-gas grid Scotland. So very clearly there are some limitations to what we can do here. However, in addition to the direct household cost savings, there's also significant added benefit of improved thermal comfort levels through the fitting of smart controls. Our work has shown the importance of all 3 mechanisms when it comes to accessing domestic heat flexibility to help reduce curtailment. And that is, firstly, smart controls which optimize heating systems. These deliver significant financial and environmental benefits in their own right. Then there are the time of use tariffs. They were significant in further reducing the amount of wind curtailment, and our analysis demonstrates that market-led time of use tariffs provide a strong signal for households to modify their heating loads. And lastly, we have the direct wind consumption financial incentive, and this also amount of curtailed wind otherwise. Taking a look at the key recommendations arising from the 4D Heat project, when we started the project, we suspected that some of the key recommendations might center around continuing to reform ESO and DSO services, as well as refining our work through further analysis. While these recommendations do hold true, we uncovered a number of other unexpected recommendations. That leads to point 3. DSOs and the ESO being a proactive voice on energy supply market reform, for instance by advocating an acceleration of mandatory half-hourly settlement. And this recommendation comes from the fact that we saw so much benefit from the homes adopting those dynamic time of use tariffs. And point 4, supporting the evidence base for smart controls. Smart controls deliver significant benefits, and we need to ensure now that heating assets being put in are fully controllable. On point 5, in terms of adopting a market-enabling role for industry innovation, there may be a role for wind developers and operators to work more closely with end users through novel local energy market mechanisms. This might be supported by government, but it also requires collaboration from DSOs for instance by adopting a market enabler role on networks capacity trading. And finally, a further example of looking beyond silos, we know that a main focus or large focus of Ofgems is vulnerable customers. So we need to think, how might DSOs and the ESO support fuel-poor homes to make them heat flexibility ready? What this all adds up to is the need for a whole system real-world view. On whole system, since 4D Heat highlights there's a strong case to engage even more proactively with wider energy market reform and end-user propositions. And on real world, so many of the issues to address are practical. They require coordination of actors and new commercial and customer propositions. It's time to be probing real-life empirical efforts, not just testing abstract concepts. So it's certainly been a journey and one that's challenged us to think much more expansively. Thanks everyone, that's all I have to present for you today. There's a huge amount more detail in the report that is now publicly available on SSEN's website. You can follow the link there or search Google for the report. Thanks very much for joining me today.